Hello, I'll be solving this mechanics paper 4, 9709 variant 42, February, March 2022. All answers have to be given to three significant figures and one decimal place in the case of angles. And the exertion of due to gravity, we need to use the value of 10 meter per second square, okay? And if you get an exact answer, you can keep it that way. That's totally fine. So for question number 1, it was relatively simple. A crane is used to raise a block of mass 600 kg vertically upwards at a constant speed through a height of 15 meters. There is a resistance to the motion of the block with which the crate does 10,000 joules of work to overcome. Okay. So there's work done against resistance and the height of the block is increasing. So what do you guys think? It's gaining gravitational potential energy, right? So we can find out the GPE using MGH, which is 600 into 10 into 15. That gives us a value of 9,000 joules. Now, what is the work done by crane? It's actually equal to work done against resistance, right? Plus gain in potential energy. So 10,000 plus 90k, that's 100,000 joules. Hopefully that makes sense. Given that average power exerted by the crane is 12.5, find the total time for which the block is in motion. We know that power is actually equal to work done by time. So the power is 12,500 watts. That's equal to the total work done, 100,000 by time. So time is equal to 100,000 by 12,500. Okay. 8 seconds. Since this is exact, right? I don't need to write it to three significant figures. For number 2, a particle P is projected vertically upwards from horizontal ground with speed u. It reaches a maximum height of 20 meters, okay? Reaches a maximum height of 20 meters above the ground. Find the value of u. So we're going to use the equation of motion. V square is equal to u square plus 2s. So why am I using this? Because I know that final velocity is 0. And the exertion is going to be minus 10, by the way, okay? So plus 2 into minus 10 into s. 0 is equal to u square minus 20. The value of s is also 20, right? Since it's a height of 20. U square is equal to 400. So u is actually equal to 20 meters per second. Find the total time for which P is at least 15 meters above the ground. So just think about it. If this is the ball, right? If it's projected upwards, this is its maximum height, 20 meters. Suppose this is 15 meters. This one. So we want to find the time for which it's above 20 meters because the motion is going to be like this. So it's going to cross this mark 2 times, right? We can actually figure that out. How? The best equation of motion to use is s is equal to ut plus half at square. I just want to find out when it crosses that point. So 15 is equal to, what was u? 20. 20t plus half into minus 10t square, or 15 is equal to 20t minus 5t square. 5t square minus 20t minus 15 or plus 15, sorry, is equal to 0. T square minus t square minus 4t plus 3 is equal to 0. Solve this. What are you getting? T is equal to 3 or 1, right? So we are crossing the first time at 1 second and the second time at 3 seconds. So how long are we above 15 meters? Total time is equal to 3 minus 1, which is 2 seconds. Okay, that is our answer. A car of mass 5 mkg is towing a trailer of mass 300 kg down a straight hill. So it's towing a trailer of mass 300 kg down a straight hill inclined at 3 degrees to the horizontal at constant speed. Okay, so this is our hill. Now we have our car here. It's actually pulling this trailer This is 3 degrees at constant speed. So there's no change in Ke, okay? There are resistive forces on the trailer, and the total work done against the resistance of 50 meters in a distance of 50 meters is 40,000. The engine of the car is doing no work. Okay, there's no work done by the engine, and the tow bar is light and rigid. So what's the energy conversion? Basically, since it's going down the hill, it's losing GPE. Okay, so the loss in P is actually being converted to the work done against resistance, and since it's constant speed, no since it's constant speed, so no K, there's no change in Ke. Okay, so let's try to do this. We can find out the height easily. We know that the distance they move is 50 meters, right? If we draw the triangle, this is the distance they move. This is 3 degrees. So we want to find out the height. What's the height going to be? Sine 3 degrees is equal to opposite by hypotenuse 50. H is equal to 50 sine 3. This is it. So now let's do this. So loss in PE of the system is actually equal to work done against resistance. So we know the loss in P is mgh, right? So what's the total mass of this system? The trailer is 300 kg and the car has mass m kg. So it's actually m plus 300 into g into height. The height is 50 sine 3 is equal to the work done against resistance of 40,000. Okay, so m plus 300 into 10 into 50 sine 3 is equal to 40,000. So if you solve this, what are we getting? 40,000 by 10 by 50 divided by sine 3 minus 300. I'm getting an answer of m is equal to 1228.59. So to 3 sig fig, it's 1230 kg, okay? 1230 kg, approximately. There was another way though. You could do this using Newton's second law. Basically using the distance, right? We know that work done is equal to force into distance. We could find out the resistive force. 40k is equal to force into 50. The resistive force would be equal to 800 newtons. Now we could form an equation using F is equal to ma. Since there's no increase in speed, the net acceleration is 0, right? So what's the downward force? mg sine theta, or m plus 300 g sine theta. Mg sine theta minus the resistive force of 800 is actually equal to 0. So if you solve this equation, you could also get a value of m. This works as well. Zero-ish, because they didn't tell you to use an energy method, right? The resistance of the trailer is 200 newtons. Find the tension in the tow bar between the car and the trailer. Okay. So let's look at this scenario. This is the car and this is the trailer. They're moving down. So if you consider, you can do the sum in two ways. Let's consider the car at first. What are the forces acting on the car? It has a component of weight down, right? Okay, let's do the trailer first because the force is already given. If you think about the trailer, the tow bar is actually pulling it forwards and it also has a component of weight downwards. So what can we say? F is equal to ma, right? And the component of weight, what was the mass of the trailer? 300 kg, right? So 300 g sine theta plus the tension in the tow bar, it's actually helping it, plus tension, right? Minus the resistance, 200 is equal to ma, or is equal to 0 because the resultant force is 0. So 3000 sine 3 plus tension is equal to 200. I'm getting a value of t is equal to 42.992, which is rounded off to 43.0 newtons. Okay, so this was considering the car. What if we wanted to consider, sorry, considering the trailer, what if we wanted to consider the car? So basically the total resistive force, remember, that was 800. So we can actually find out the resistive force on car. What's it going to be? 800 minus 200, that's equal to 600 newtons. Okay, now for the car, what's happening? The tension is actually acting backwards, right? So mg sine theta minus tension minus the resistance 600 is equal to 0. So what was the value of m? It was 1230, right? 1230 into 10 into sine 3 minus 600 is equal to t. There's a problem with this though. We're not using the exact answer, right? So 1228.59 into 10 into sine 3 minus 600. Yeah, we're getting a value of 43.0 as well. This is fine. So it's totally your wish, but the one considering the trailer is much easier. You save a lot of time. Now for number 4, we had 6 sums in this question paper, by the way. For number 4, the total mass of a cyclist and her bicycle is 70 kg. The cyclist is riding with constant power of 180 watts up a straight hill inclined at an angle of alpha to the horizontal. Okay, so the cyclist is going up a hill. We know that sine alpha is equal to 0.05. What is that? Just press that on your calculator. You're gonna get sine alpha is equal to 1 by 20. Okay, so we can actually find out the angle as well. Sine inverse 0.05. That's 2.87 degrees, but we don't need that, right? So at the instant when the cyclist speed is 6. So do you see this wording? At the instant, they're actually telling you to use P is equal to FV, right? There's constant resistance to motion of F. Let's find out the value of F. We're just going to use resultant force is equal to MA, right? So we are going up the hill. We are going up the hill, right? And the weight, the component of weight is downwards, and the resistance is also downwards. So let's form the equation. We're going up the hill, so driving force is going upwards, minus mg sine theta minus the resistive force F is equal to ma. So what about the driving force? We know that P is equal to, show this on the right hand side or somewhere, P is equal to Fv, so driving force is equal to power by velocity. That's actually equal to 180 divided by 6 at the instant when it's 6. So the driving force is 30 newtons. So 30 minus 70 g sine alpha, which is 0.05, right? Minus F is equal to 70 into minus 0.2. Okay, 70 into minus 0.2. So what do we get ultimately? 30 minus 70 into 10 into 0.05, 35, minus F is equal to 70 into minus 0.2 is minus 14. So F takes a value of 30 minus 35 plus 14. F is equal to 9 newtons exactly. That is your answer. Okay, good sum. Next, find the steady speed that the cyclist could maintain up the hill when working at this power. Okay, so for a steady speed, right, what happens to the net force? Net force is actually 0. Resultant force is equal to 0. This is what we need to know for a steady speed. That means the forward force is actually equal to the backward force. So what's the forward force here? Actually, the driving force, right, minus the component of weight, mg sine alpha, minus the resistive force F. That's actually equal to 0. So we know that driving force is P by V minus 70 G 0.05 minus 9 is equal to 0. Now the power is constant at 180. 180 by V is equal to 9 plus, what was this value again? 17 to 10 into 0.05? 35. 9 plus 35. Okay. So 180 by V is equal to 44. So V is actually equal to 4.09 meter per second, okay, to 3SF. That is your answer. Let's go to number 5. So 4 coplanar forces act at a point. Okay, they are in equilibrium. This is your keyword. This is what you're going to look for. So net force is actually 0 in all directions. So let's equate all, horizontal forces first. What do we have? We have F, we have a component of G, and we have a component of twice F. Okay, so resultant X is equal to 0. We can write this G cos 60 plus F is equal to twice F cos 40. See if that makes sense. That was for the horizontal direction. We can simplify this further. Half G plus F is equal to 2F cos 40. Okay, let's just keep it that way. Now, what about the vertical direction? In Y direction, right? So G sine 60, right? G sine 60 plus 2F sine 40 is equal to 10. G sine 60 plus 2F sine 40 is equal to 10. Root 3 by 2G plus twice F sine 40 is equal to 10. So let's solve this. We can basically use substitution. Okay, let's just use substitution. I'm just going to rearrange this equation over here. Half G is equal to 2F cos 40 minus F, right? Or G is equal to 4F cos 40 minus F, right? So I'm just going to substitute this over here. Root 3 by 2 into 4. Sorry, it was 4F. Okay, I'll just keep this outside. That's better, right? Yeah. 2 times this. So I'm substituting this inside here below. 2 times 2F cos 40 minus F plus 2F sine 40 is equal to 10. 2 root 3 F cos 40 minus root 3F plus 2F sine 40 is equal to 10. If you take F common, what do you end up with? 2 root 3 cos 40 minus root 3 plus 2 sine 40 is equal to 10. Let's solve this. I'm getting something like 2.20718 F is equal to 10. 10 divided by answer is 4.53. F is equal to 4.53 newtons. Now if you want to find out G, just input this over here. Over here, G is equal to 2 into 2. Okay, so 2 into answer into cos 40 minus answer into 2. I'm getting a value of 4.82. So these are our answers, 4.82 and 4.53. Okay, so this is one way of doing it. You could also substitute if, right? You could write a solution in terms of G. That would work as well. So this one was interesting actually, the next one. Given that F is equal to 3, find the value of G for which the resultant of the forces is perpendicular to the 10 Newton force. So we want the resultant force, right? We want the resultant force to be perpendicular to the 10 Newton force. That means since it's perpendicular to the 10 Newton force, which is vertical in direction, that means the net force is in the horizontal direction. Or we could say that the forces in the vertical direction actually cancel out. That's the logic. There will be no force in the vertical direction since the net force is in the horizontal direction. So how can we do this actually? Let's cancel the vertical forces out. So it's actually G sine 60, right? Plus 2F sine 40. G sine 60 plus twice F sine 40, okay, is actually equal to 10. If the vertical forces are cancelled out, we only end up with a horizontal force. And we know that the value of F is 3 actually. So G sine 60 plus 6 sine 40 is equal to 10. Just solve this. 10 minus 6 sine 40 divided by sine 60. We get a value of G is equal to 7.09 newtons. That's it. That's your answer. Now we're doing the last sum. Oh wait, no. We have two more sums. A cyclist starts from rest at a fixed point O and moves in a straight line. Before coming to rest k seconds later, the acceleration of the cyclist at time t seconds after leaving O is a meter per second square, where a is equal to this for 0 to k. Find the value of k. So the cyclist comes to rest k seconds later. So coming to rest, what does that mean? Velocity is 0, right? So let's find out velocity first. A is equal to t to the power minus 2, minus half I mean, minus 3 by 5 t to the power half. So what is velocity gonna be? It's just going to be the integration of this. So 2t to the power half divided by half minus 3 by 5 t to the power 3 by 2 divided by 3 by 2 plus c. Okay, so we end up with v is equal to 4 t to the power half. 3 by 5 divided by 3 by 2 is 2 by 5 minus 2 by 5 t to the power 3 by 2. Wait, I'm just gonna write this here. Plus c. Okay, so here's the thing. We start from rest, right? So at time 0, v is equal to 0, right? So c is also equal to 0. Okay, so this is our equation. V is equal to 4 t to the power half minus 2 by 5 t to the power 3 by 2. Okay, now we want to know when do we come to rest. When is v actually equal to 0? So 4 t to the power half minus 2 by 5 t to the power 3 by 2 is equal to 0, right? So if you take t to the power half common, what do you end up with? 4 minus 2 by 5. You guys do know that t to the power 3 by 2 is composed of t to the power half into t, right? It's 1 plus half. So we just have t to the power 1 left. So 2 by 5t is equal to 4, right? 4 into 5 by 2. We get a value of t is equal to 10 seconds. That's our answer. This is when the cyclist comes to rest again. So k is actually equal to 10. Okay, that's it. Now we want to find out the maximum speed of cyclist. To find any maximum points, we need to equate d square y by dx square. We need to equate dy by dx with 0. So what is the derivative of velocity? It's acceleration, right? So we just need to equate acceleration to 0. So acceleration is 2t to the power minus half minus 3 by 5 t to the power half, right? Let's equate this 0. How do we solve this? So there's actually an easy trick. I'm going to teach you. So you can actually take t to the power minus half common here. Okay, so you can only apply this trick when you have t to the power minus half and t to the power half. I'll tell you why. Check this. Suppose you have x to the power half, right? It can be written as x to the power half into x to the power minus half divided by x to the power minus half. I'm essentially doing rationalization because these actually cancel out. We actually end up with x to the power half only, right? So you can write x to the power half like this. So if you take x to the power minus half common, if you take it away from here, right, what do you end up with? X to the power half into x to the power half, or it's just x to the power 1. So this is the trick. You can use this in differentiation as well when you're applying quotient rule. It comes in handy basically. So I'm going to apply that trick. I'm going to take away t to the power minus half. So what am I left with? 2 minus 3 by 5 t to the power 1, right? That's the trick I applied, is equal to 0. So one of them is going to be t is equal to 0. So That's probably not it, because at time 0 we know that we had 0 velocity, right? The other one is 3 by 5 t is equal to 2, or t is equal to 2 into 5, 10 by 3 seconds. This is the time at which we have maximum velocity. Okay, so we know that velocity is 4t to the power half, right? Minus 2 by 5 t to the power 3 by 2. So if we apply t is equal to 10 by 3 over here, what does velocity become? 4 into 10 by 3 to the power half minus 2 by 5, 10 by 3 to the power 3 by 2. Okay. I'm getting a value of v is equal to 4.87 meter per second. That's the maximum velocity. Okay. Interesting sum. Finding expression for the displacement. Okay. In terms of t, hence find the total distance traveled by the cyclist from the time at which she reaches her maximum speed until she comes back to rest. Okay. So here's the thing. At time 0, we had a velocity of 0. At time 10, we also had a velocity of 0. That's what we proved in the first part. Now, at time 10 by 3, we had our maximum speed of 4.87. So they actually want us to find this distance, the one from 10 by 3 to 10 seconds. Okay, so let's find out an equation for displacement first. I'm integrating velocity. What do I get after integrating velocity? It's going to be 4t to the power 3 by 2 divided by 3 by 2, right? Minus 2 by 5t to the power 5 by 2 divided by 5 by 2 plus c. Or s is actually equal to 8 by 3 t to the power 3 by 2 minus 4 by 25 t to the power 5 by 2 plus c. Okay, so we want to find out the distance between these 2 points, right? How? We need to apply limits. So it's 8 by 3 t to the power 3 by 2 minus 4 by 25 t to the power 5 by 2 with limits 10 and 10 by 3, right? Now let's do it. Come on. So 8 by 3, 10 to the power 3 by 2 minus 4 by 25, 10 to the power 5 by 2 minus 8 by 3, 10 by 3 to the power 3 by 2 plus 4 by 25, 10 to the power 5 by 2. Just solve this. You don't show the breakdown. Do it step by step though. 10 to the power 3 by 2, right? Into 8 by 3. You can show it to an appropriate number of significant figures. 84.327404 minus 10 to the power 5 by 2 into 4 by 25 minus 50.59644, right? Minus 10 by 3 to the power 3 by 2 into 8 by 3 minus 16.22882 plus, oh, I used 10 here, right? It should have been 10 by 3. That's why it wasn't matching. My bad. 10 by 3 to the power 5 by 2 into 4 by 25. 3.24576. Okay. I'm getting a value of s is equal to 20.7 meters. That is your final answer. Okay. To 3SF. Okay, let's go to the last one, number 7. Tricky sum. A bead A of mass 0.1 kg is threaded on a long, straight, rigid wire which is inclined at sine inverse 7 by 25. So we know that sine theta is equal to 7 by 25. So let's find out the angle. Actually, we don't need to find out the angle. We can find out the ratios. If this is theta and this is 7, hypotenuse is 25. What's the other side gonna be? 25 square minus 7 square, root over answer, which is 24. It's a common ratio, right? So A is released from rest and it moves down the wire. So the slope is approximately sine inverse 7 by 25 is 16.3 degrees. It's somewhat like this. So this is A. When we release the string, right, it started falling down. Now there's friction between A and the wire. That's mu. Oh, we don't have a slope actually. There's just a wire. It's threaded along this wire. We just have a wire. It's threaded along this, and it's just like inclined. It's inclined. So it's falling down. There's friction between the wire and A. So when A has traveled 0.45 meters down the wire, its speed is 0.6. Okay. So why is A falling down? It's due to gravity, right? We haven't applied a force. So we can actually say that, we can apply the equation of motion. V square equals to U square plus 2S. So 0.6 square is equal to 0 plus 2 into 0.45 into A. Let's find out A. 0.6 square divided by 2 divided by 0.45. A is 0.4. Okay, next. We're going to apply Newton's second law, F is equal to ma. What is the forward force? The component of weight, mg sine theta. And the backward force is friction. Mass is 0.1 kg. So 0.1 g. Sine theta is 7 by 25. Minus friction, that's going to be equal to mu r is equal to 0.1 into 0.4, right? So friction or mu r is actually equal to 0.1 into 10 into 7 by 25 minus 0.1 into 0.4, which is 1 by 25. Mu r is equal to 6 by 25. Now we need to find out mu, right? So what's the value of r? So r, the value of r, right? If we imagine it to be a slope, right? It's this component over here, cos theta. So mu into mg cos theta or alpha is equal to 6 by 25. So cos alpha, right? Cos theta is actually adjacent by hypotenuse 24 by 25. Okay. So mu into 0.1 into 10 into 24 by 25 is equal to 6 by 25. Mu into 24 by 25 is equal to 6 by 25. Let's solve this. So mu is equal to 0.25 shown. Okay, that's all. Now the last part, this was the most complicated sum in the question paper. Another bead B of mass 0.5 kg is also threaded on the wire. At the point where A has traveled 0.45 meters down the wire, it hits B, which is instantaneously at rest on the wire. Okay. So this was the original scenario. A was moving down, right? Now there's another wire B over here. Now A hits B. A is moving towards B and it hits B. B was at rest initially. Now A is brought to rest after the collision. So we can say this, we can use conservation of momentum. Sum of momentum before collision is equal to sum of momentum after collision, right? So what's the velocity of A before collision? It was 0.6, right? 0.6 and mass is 0.1. So 0.6 into 0.1, right? Plus 0 is equal to A comes to rest. So A becomes 0 and B becomes, 0.5 into v. This is what we test to find out. So 0.6 into 0.1 is equal to 0.5 into v. We are getting a value of v is equal to 0.12 meter per second. Okay, that's all. This is the velocity of B right after the collision. Okay, now let's check this out. What's happening afterwards? After this collision occurs, this is where the collision occurred. A just hit B right now. Now after the collision, B starts moving, right? And A comes to rest temporarily. But then find the time from when the collision occurs until A collides with B again. What does that mean? A is gonna hit B again soon. So we need to find the time taken from this point onwards, right? Considering this instance 1 till this instance occurs, like when they collide again. So A will catch up to B and collide again. This is instance 2. So we need to find the time period between these two collisions. How? So let's find out the acceleration of B first, right? So we know that F is equal to ma. For B, it's gonna be mg sine theta minus friction, right, is equal to ma. So 0.5 into 10, right? The sine theta was 7 by 25 minus mu r. Mu is 0.275 into mg cos theta is equal to 0.5 into a. Seven by 5 minus 0.275 into 0.5 into 10 into what was cos 25 again? 24 by 25, right? Yeah, is equal to 0.5 into a. Let's just find out a directly. Okay, I'll just do this for you guys. 7 by 5 minus 33 by 25. So we're getting a value of a is equal to 0.16 meter per second squared. This is the exertion of a. I mean B. This is the exertion of B. What about the exertion of A? We had that from the first part, right? It was 0.4. So let's form two equations now. For SA, the one behind, it's going to be, like, we're going to use S is equal to ut plus half t squared. The examiner wants to see that. SA is equal to 0 plus half into 0.4 into t square, or SA is equal to 0.2 t square. What about SB? SB is going to be, it has an initial speed now, right, of 0.12. We just found that out. 0.12 plus half into 0.16 into t square. So SB is equal to 0.12 plus 0.08 t square. Now we're ready. So if a particle is behind another one, if it wants to catch up with it, we basically equate the distances. Okay, and right after they collided, right, there was literally no distance between them. The s between them was 0. Nobody had a head start, right? So we can just go for SA is equal to SB. 0.2 t square is equal to 0.12 plus 0.08 t square. Okay, so 0.12 t square is equal to 0.12. T square is equal to 1, and t is equal to root over 1, which is plus minus 1, but we can only take the positive value, right? So the answer is 1 second. So 1 second after the first collision, they collide again. Hopefully I could clarify things. If you have other questions, you can ask me. Okay.